them if you want to review for the exam. You know, I'm not going to strong arm you to turn them in, but you can turn them in if you want. And get ready to pay your fine so we can get those out of the way. Right.
It's well loved.
Throw it against the wall?
No, it's called doing math homework. Gets a little intense sometimes.
All right. Settle down.
It's like they fermentation.
All right, let's take a look at number 3 here. We got the answer. F prime of x is negative 1 over x squared. Let's kind of work through there using the definition. So for f of x is 1 over x, the derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, and so we just use that to generate the function. Now, in this case here, we're going to get the limit as h goes to 0 of 1 over x plus h minus 1 over x all over h. Well, that's kind of the end of the calculus. Everything after this is just algebra. All you got to do is take that and simplify it. And so we just got to know, and you got to understand, it's very helpful to understand all your little algebra rules, especially for next year. F prime of x now is limit h goes to 0. All right, what's my, got to get a common denominator on top. What's that going to be?
It should be x squared plus h x, and then.
All right, you're going a little bit too far.
All right.
How about x times x plus h to start with?
Yeah.
All right, so you got to take this x times x plus h, and then we'll distribute here in a second. So this piece over here needs an x, and then it's going to be x plus h, or x times x plus h here, minus that needs an x plus h, and that's all over h. Okay. We can distribute that x and make it x squared plus xh, that's fine. But what are we going to get in the top? You got x minus x plus h, and when you simplify it, what are we going to end up with? Just negative h. So that's going to be up here. So I got f prime of x equals the limit as h goes to 0 of negative h over x squared plus xh all over h. Now, take your top here, divided by, you cannot have a complex fraction, so we're dividing by h, which is the same as multiplying by 1 over h. So we get f prime of x equals the limit as h goes to 0 of negative h over x squared plus xh times 1 over h. Now those cancel. Those cancel. And we get f prime of x equals limit h goes to 0. We're left with negative 1 over x squared plus xh. All right, is that, at this point, can we do anything else? Can we simplify it any further? You're shaking your head, yes. What do we do? Okay, all right. Oh, that'd be taking the limit, so we're miscommunicating here. Simplifying in terms of algebraically, we're done. We can't do anything else. So at this point, we take the limit. You take the limit, you let h equal 0. And like I said, there is a lot of math behind that we're just glossing over because you can understand just boom, let h equal 0. So that term ends up being a 0. At this point, you do not have to write limit as h goes to 0 because we took the limit and we get negative 1 over x squared. So that's the function. You want to know the derivative at 2, you plug in 2. You want to know the derivative of -5, you plug in -5. It'll give you the slope at that point. Okay. All right. Any questions on 1 or 2 though? As we go through there, need to be able to do those as well. All right. We're going to do a little bit more with this today and a little bit more tomorrow, and then we'll kind of get back into review for the rest of the week and starting on Wednesday for that. All right, I got you wrote this down last week, but if you got a function, the derivative, 3 main things. If the function is increasing, then the derivative has to be positive. If the function is decreasing, the derivative has to be negative. And if the function is at a max or min, then the derivative has to equal 0. We're going to use that to sketch what we call derivative graphs. All right, I'm going to hand this out, but take a look at A and B. While I'm doing this, I'm going to hand this out to you. You are going to sketch the derivative graph. Go. Oh, sure.
Yeah, we got stuff. Home.
Hope you get that.
Left into that.
Okay.
Yeah. At Rodonia. Yeah, it is a straight line, isn't it? Is it straight or is it horizontal?
All right, A. They give you the equation. It's not absolutely necessary, but what's the derivative going to look like? Let's see if this is making any sense. Okay, Cole Rose. Any idea?
Not really.
Not really? No?
Would it be a horizontal line at y equals 1/2?
Would it be? Yeah, it would be. Because what is the slope of this line? If you take a look, you go up 1 over 2, up 1 over 2. So that slope is 1/2. So the slope at any point is going to be 1/2. So is this case here, we're going to estimate for a few of them or most of them, but this one here would need to be exact. Okay, so that's going to be this horizontal line, f prime of x. Hold on. F prime of x equals 1/2. So you just got to understand that any point on that line has a slope of 1/2. There's not changing. All right, now the others we're going to estimate. There's some key points you have to hit, but then there's some other things that, it just doesn't have to be exact. All right, the graph of x squared minus 2 looks like this. What's its derivative going to look like? First thing you want to identify, is there a max or a min? Well, yes. What is the derivative at that point? What is the derivative at a max or min? What is the slope, right?
0.
0. So that means that if I'm graphing the derivative, that the derivative equals 0 at that minimum. What's happening to the left and what's happening to the right? Okay. To the right, let's go to the right of that point. Is the graph increasing or decreasing? Is increasing, so that means that the derivative has to be what? Positive. So f prime of x for here has to be greater than 0. What's happening to the left of that point? Oh, hold on. To the left of that point, is it increasing or decreasing? Decreasing. So that means that the derivative, f prime of x, has to be less than 0. I'll give you a little bit of a clue. The derivative for a quadratic will be linear. The derivative for a quadratic will be linear. So using that fact that we just did, what will the derivative look like? Like you said, doesn't have to be exact, but there's some key points. So think about that. Derivative of quadratic is linear. We know that the green portion, it's gotta be less than zero. The red portion's gotta be greater than zero. So what's the final equation gonna look like? Okay, it's gonna be linear. It has to go through that point, and it has to increase from left to right. That will be your derivative graph. Now, I don't know what the slope is of this line. Okay, I could figure out, but I'm not gonna worry about it. Okay. So you just need, you just need to show that it is increasing. You just need to show that it is increasing. Okay, and it has to hit zero at that key point. All right, I want you to look at the third one. This one is a good one. This is right here. It's gonna keep going up, and it's also it's not gonna go below the x-axis. I want you to think about it. You got a pencil? Try it. Maybe think about sketching what the derivative would look like, what you think it would look like. I wouldn't do it in pen. All right, so think about that. Take a second. True. But yeah,
No solution.
So the reason there's a solution is there's a slope at every point.
Yeah.
Yeah, so you gotta have a graph. I think it's right.
Oh, not yet. Cal, I'll take it over here. Josh? I have no idea.
That is Every time we align one like this though.
It has to look.
Yeah,
Yeah, I
not
think so.
necessarily. Yes, necessarily. That's how it works.
Can we walk through it?
Yeah, negative.
Oh, what do you do?
Yeah,
that's like.
That's what I said.
It's way cheating. Okay, first thing, tell me why this is wrong. Tell me why this is wrong. Okay,
Because it's always increasing, so it couldn't be negative, and it's zero, but there's no min or max.
okay. Yeah, those two key things. And then some of you like drew it to right to here as well, like thinking that would work. But you got to think the line has to continue infinitely. If you draw it straight at any point, it's got to continue straight. So Cooper had the right reasons here. At this point here, you're saying the slope is zero. If the slope is zero, that means there is a max or a min at that point. Clearly, there's not. And also, anything below here is saying, all right, my slope is now negative. So it cannot be it cannot be a straight line because it would have to continue and go into the negatives. So it can't do that. Slope, as you look at that line, is it positive or negative? Okay, the slope of the curve, right? Positive. At all points, it is positive. Okay, so it's positive here, it's positive here, here. Is the slope getting steeper or is it getting flatter? Getting steeper. So how do we account for everything? It always has to be positive, and it has to increase as we go from left to right. So your graph is going to look basically like the original. So it's going to always be positive, and its slope is going to increase. So it has to be almost the same shape. Okay, so I'll be very close to that same shape. So here's the key things you got to take out of that. All right, I know it doesn't hit zero. There's no maximum in. I know it can't be negative. And as I move from left to right, the graph gets bigger. Or the slope gets bigger. So, I guess it's hard. The first time you see it, it's not going to make sense. So hopefully, though, at least now you can understand. All right, D, cosine of x. So this is from negative pi to pi. So one thing you got to remember is at this point here, remember, it will bounce back up and continue. Okay, and so right here, it'll bounce back up and continue. Got it? I mean, so understand what cosine looks like. All right, what's the derivative gonna look like in between negative pi to pi? First thing I want you to identify, are there any points where the slope is 0? Any maxes or mins? Yeah, how many? 3 of them, because this would be a min right here, so that means my derivative has to be 0. This is a max right there, that means my derivative, oops, that's in the wrong spot. Means my derivative is 0. I got another min right here, which means the derivative is 0. So those 3 points. If your original graph is continuous, your derivative will be continuous. Okay, so there can't be any breaks in there. All right, but what's it gonna look like? It has to hit those 3 points. What's it gonna look like in between? All right, let's go from the left. Let me erase a little bit. Let's go in between those first 2 zeros. Okay, let's just look at that piece. Slopes, positive or negative? Always positive, right? Okay. As we move from the left to the right, the slopes start to get steeper. They start to get steeper, but then what happens is we get closer to this point here, they start to flatten out. But it's always positive. So here's what it's going to look like. It's going to look like that. So this is a positive slope. At this point here, that is your steepest positive slope. Now I had to estimate a little bit. So at that maximum on the derivative graph, and I don't know how high it actually goes. That's, right now I'm not too concerned where you put that, as long as you get that general shape. All right, what's going to happen though between the next 2 points? Okay. What's going to happen between those? This piece here is it's a decreasing graph. So it means their slopes are negative. Where would the steepest slope be? Probably be right around in here. And then it starts to flatten back out. So it's going to look like that. And like I said, I'm not totally concerned about how high or how low this goes, but I'm just concerned that A, this is always positive. It hits 0 here and here, and then these are always negative. So there's your derivative graph. All right, look at E. Don't cheat on me, Jacob. All right, what do you think E would look like?
It's gonna be a problem.
And why,
Yeah, I wish.
Cheated.
I didn't actually know that.
Well, yeah. It will be. It will be. All right, think where it's 0, think where it's positive, think where it's negative. Okay, those are the key things. Where is the slope 0? Where is the slope positive? Where is the slope negative? And I can give you a little clue, Jacob. Jacob kind of looked ahead. I will tell you that it is a parabola. Use that fact. The graph will be a parabola.
You're right. This would be positive. This is more physics. This is just like right velocity. Aaron, that's how I'm understanding it. Just think of it as velocity versus time and acceleration versus time.
Oh my god.
That's what it is. It's just no wonder people say organized physics is so cool because it's just this.
Oh.
That's what you can watch that one too.
All right, so the key thing here. And now here's a little bit, and you'll get into the details. If you have a cubic function, the derivative will be 1 degree less. So if you have an x squared function, your derivative will be linear. If you have a cubic, your derivative will be a parabola. Now there's a lot of math behind that, but that's just a quick guide. Where does it equal 0 at? And this is where you have to be a key where your point is. The slope of the max or the min, right there. So you have to go directly down at that x value that has a slope of 0. And it has to be in line. Same thing here with this. Looks like it's about right there. That has to be the slope. All right, what's going on in between here? Is it decreasing or increasing? It's decreasing function, so the slope is negative. It starts out, it's at 0 here, then it's negative, and then it gets very steep, and then it comes back to 0. But it looks like the steepest point is somewhere probably right around 0. So that means this whole time, it's got to be a negative slope. So it has to be underneath there. All right, what's happening to the right? Now, since this is cubic, it's going to keep going on forever. And it's going to keep getting steeper and steeper and steeper. So that means it goes positive, and then this is just going to keep getting steeper. This tends to be the hardest because you got to think about it from left to right and align it in some ways. If you go this direction, it starts at 0, okay, and then this is a positive slope. That would be a positive slope. That's a steeper positive slope. So as it moves away from there, the slope is positive and it gets bigger. So that's where we get that parabola from. Okay, that's where we get that parabola from. So this says, all right, my slope is positive and it's going to keep getting higher, higher and higher and higher. That would agree with this piece. Same thing over here. Everything underneath here is negative. So what I want you to be able to do is take a graph and then come up with the derivative graph of that. All right, we're going to do a couple things on the back. I'm going to give you some conditions. You are going to give me the graph. All right, blank in the graph.
You got it. Take my next one.
Oh, yeah, you ready? Yeah, that's right.
What happens to everybody? Yeah. Ah, shoot.
Now you are graphing the original function. You're not graphing the derivative.
Oh, wow.
Oh,
Oh.
well.
Oh.
You're graphing the original function. You're not graphing the derivative. So if you got a straight line, that's wrong.
That's good. Hey,
No. No, so your original function is f of x, and then the derivative, those are the conditions of the derivative. So for anything less than -2, that means the slope is positive.
Oh, I see.
For anything bigger than -2, the slope is negative.
This.
And
Just think on this side.
for x equals -2. What has to happen at x equals -2? Gotta have a what?
0.
As the slope is 0,
Maximum.
maximum or
Minimum.
minimum. Gotta have it. If x equals -2, we gotta have some type of maximum minimum. Okay? To the left of -2, your slope has to be positive, which means your graph has to be increasing. And after -2, my slope is negative, which means my graph has to be decreasing. All right, what's that gonna look like?
Parabola.
with the minimum at -2.
All right, he's close, not 100%. Let's look at why he's not 100%. So here's -2. This minimum could occur anywhere. Wait a minute, that didn't help. All right, what's wrong about that?
Left side is decreasing, but it should be increasing.
Yeah, on the left, we want it to be greater than 0. So we want slope. So what's the only thing I need to do? Flip it, and instead of making a minimum, make it a maximum. So there's a parabola. And instead of a minimum,
Oh,
okay? That will satisfy all those conditions. Okay. We good? All right, similar idea here. Sketch the graph of a quadratic function. Y is quadratic. Y equals f of x, for which f of 0 equals 3, f prime of 0 equals -8, and f prime of 2 equals 0. All right, what's that going to look like? Now, like I said, some of this can be approximate, but there's a couple of things that have to be, a couple of conditions that have to be met. Now remember, you're graphing f of x. You're graphing f of x.
Is that the two? Yeah, this is a little bit slow.
This might be.
It's better than I don't know.
Okay, so that f of 0 equals 3. So they also said f prime of 0 is -8. 0. That has to have a negative slope.
And
Add 0. Add 0. All right, a couple things. Now it flips back and forth. It has f of 0 and f prime of 0. Those are two different things. F of 0 is 3. That's a point. It has to go through that point. And when it goes through that point, it has to have what type of slope? Negative, which means is it increasing or decreasing? Decreasing. What happens at f? What happens at 2? Since the derivative equals 0, what has to happen? Has to be a max or a min. Well, if you kind of look at all the information, it's going to have to be a min. And so if this is 2, so it's going to look something like that. The slope right here would have to be -8, has to be decreasing. The slope there is 0, and it hits f of 0 equals 3, hits all my conditions. Okay, does that, I mean, the first time through, it doesn't, it takes a little while to sink in. Okay, that's all right. But you got to understand, like maybe once you see it, hopefully then it makes sense. Okay. All right, what I need you to do, two things we talk about. We talk about the definition, which is this one here. F prime of x equals limit as h goes to 0. It's that whole thing. And then if we estimate the derivative, we just plug in 0.1 for that h. So I'm going to ask you to do both. So if you need to use the definition, you need to set this whole thing up. If you're asked to estimate, you need to use this. What I'm gonna give you here for classwork / homework, use the definition to find the derivative for 1 and 2. Estimate the derivative for 3 and 4 for that function. So do that now. I'm gonna flex the books.
So Mr. Deal, I thought I turned into the one last week.
Yes,
Friday.
there should have been a turn in from Friday.
Awesome.
Need to get that turned in.
Yeah, I should do that now.
Let me do that.
Okay.
No, definitely shouldn't walk.
Oh, no.